Okay, so you can ignore the little parentheses. Typically what people do is they put in the expected values into there, but we're not going to worry about that. Because I'm expecting to find all of them. So the first thing we're going to do is figure out what our H0 or H1 is. I made it super straightforward. So H0 is what? O sub I equals E sub I, which means that no something. What is this one going to be?
Does not.
No relationship independent. You guys kind of follow me? So no relationship, it's independent. It's just like me. That's going to be my claim. Good. So then H1 is going to be O sub I is not equal to E sub I, which means that it would be, what's the opposite of independent? Dependent. So H1 is it's dependent. Great. So Ramsey, go ahead and tell me how to do step 2.
You would do the alpha, which is 0.05. And then you are going to say that the degree of freedom is equal to the row minus 1 times the column minus 1. So it's going to be 2 minus 1 times 3 minus 1, which is 2. Use the chi-squared table for the total value, which is 5.991.
5.991. So you're going to draw your picture over here.
That's what you have to do.
And you're going to shade it. And then that's 5.991. Great. Emily, what do you do next? Emily, what do you do
You
next?
have to find your test stat.
Yep. So you're going to do, so first you need to find your 2 expected values. Your first one and your last one. So my first one's going to be called E of what? What's my row?
E1, comma
1, comma 1. And that's going to be, how do I find that? Emily, what do I do with that one?
You have to take 1,158 times 51 and then divide it by 1945.
Good. 1168 times 51 divided by 1945. And what did you guys get for that one? 30.364. 36? Great. And the last one, what's the number for this one? E what? What row is it in?
2.
The second row, what column is it in?
3.
The third column. So E2, comma 3. So then that has a row total of 787 times 1409. And what do you guys get for that?
I think 7.
What do you get for that?
570.119.
Okay, great.
Actually went 2.
I'll leave with 1. That's good.
Okay.
We'll leave it.
No,
That's
that works.
perfect. Okay, and then we're going to do, then you put this stuff into a matrix, right? This is your matrix. You use that as your matrix. That's your matrix A. Yeah? And then you did stat, test, chi-squared test, and got chi-squared is equal to what? 37?
Yeah.
And you got a p-value of,
10 to the minus 25th.
wow.
Or 3 times 10 to the minus 25th.
Okay, once you get to like many, many zeros, that's about equal to 0. All right, well, if you get past 7 zeros,
Can't you?
you can say it's about equal to 0.
Can you just write the 3.9 whatever is?
As long as you put the E,
Yeah.
Okay.
that's fine. But like, I don't expect you guys to write 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, something.
It was 25 zeros.
Yeah.
5 zeros, yeah, that's ridiculous.
No, I think it's good. You do not have to put the p-values on the test. It's just good practice because you will have to for 11.3. So I just want you guys to get into that habit because it doesn't hurt you. You know what I'm saying? Yeah. And then we have to do, and then we can deal with all these E issues that people will hit on that you may not hit on the example. Okay.
Wait, I have a a question on
Yeah.
the test stat, the chi-squared. Don't you have to put that you're doing it of
Matrix
Oh,
A.
yeah.
matrix A?
I'm so sorry, thank you. Let me know you did make a mistake. So here you guys would put, 3 point, what'd you put, Yusuf? 3 point what?
3.97.
Oh,
Well, I did 3 sig figs or
E
whatever.
negative
25.
25, yeah. So just give me that, that's good. All right, and then we're gonna throw that in here. 112 is way out here.
Not to scale.
Yeah, pulling up the scale. Yeah, it's totally out of scale. It's way out there, but
Like maybe past the wall.
But I'm okay with that. As long as it's beyond the 5.99, then I'm happy.
I like that guy.
Yeah.
I'm gonna miss him.
I know.
He's actually helpful.
And then step 4 is going to be what?
You reject.
Reject H naught. It's totally in that area.
Totally obliterate H naught.
Obliterate it, yes,
I was
exactly.
kind of stuck. I was
Not
listening.
even
I heard
close.
this. I was like, is that him?
So then,
I went to the room.
there
Can I
is
get some
enough
popcorn? He's
evidence-
Like, yeah, I got you.
That's tricky. But not reject.
And remember, pretty much all of these are going to be reject the claim. To reject the claim that it's independent. Everybody out okay with that part? Our 11.1 and 11.2 are going to be almost always reject. On the exam, they're going to be reject. Is the camera on?
Yeah, it's
Yeah,
Okay.
I heard you do the boop earlier, bro.
Okay,
It's 3 points.
Reject the claim that that being victim
A victim of a crime is independent of knowing.
of crime is independent of knowing the criminal. Okay, good deal. Perfect. Let's take a look at 11.3, analysis of variance. So this one is different. 11.1 and 11.2 are about proportions, right? They got categories. How many people in each category? Those always have to be whole numbers, because you can't have part of a person in the category. These ones are about means, so you can totally have decimals. It's totally possible to have decimals. So here our H naught is that the first mean equals the second mean equals the third mean equals the fourth mean, however means you have. We're going to put each mean, each set of numbers. So what we're given is a list of data, several lists of data, right? So list 1, list 2, list 3, list 4 of data. We're going to put each list into its own list in the calculator, and then we're going to do use a TI calculator to do stat test ANOVA of L1, comma L2, comma L3, comma L4, and that's going to give us a p-value. Write down the f value too, because theoretically, if we had that table, we'd use the f value. But here we're going to use the p-value because it's another table. You guys don't need another table just for one section. And then, if the p-value is, remember the p-value represents the probability of getting a sample like yours. What's our guideline for unusual?
25 or less specified otherwise.
Yeah, 5% or less typically. So if the probability of getting your sample is, if your p-value is 5% or less, or whatever alpha is or less, then it's unusual and you would reject H naught. If your p-value is greater than alpha, then it's not unusual. You would not reject H naught. You didn't get something unusual, H naught should be fine, or could be fine. All right, so what we're going to do is take a look at, that's kind of what I just said. So just to kind of bring you back to the idea of this, ANOVA is comparing means. So remember we talked about having like little kindergartners and then like 6th graders, their heights, and then high school seniors. And we're looking at the between group variance between these groups, and we're comparing that to the variance just within each group. So if the between group variance is a lot larger than the within group variance, then we'll reject the H naught and say that these are not the same. But if we took, say we took high school seniors from Oregon and California and Texas, and if their between group variance is about the same as the within group variance, then we'd say, okay, the means are maybe the same, and we would not reject the null hypothesis. Everybody sort of understanding that idea? Good. Now we'll skip that one. The way we compare them is by taking that between group variance, and I'll either call it the variance between samples, or I might call it between sample variance or between group variance, and take the within group variance and you divide them, right? The between group divided by the within group, and that gives you your F statistic. So if F statistic's really big, that means that this one's a lot bigger. The between is a lot more. I will give you the between sample variance, or I might call it the between group variance, and the within sample variance, or maybe I might call it the within group variance, and ask you to compute F. It should be straightforward, because you should realize that that's where that comes from. All right, here are our steps. State your hypotheses. Again, H naught is that the means are the same. U1 equals mu2 equals mu3 equals mu4, how many means you have. H1 is at least one differs. And then step 2, just find alpha. Alpha equals blank, whatever, done. Step 3, compute your p-value by putting the first group in list 1, the next into list 2, the last into list 3, or you could have 4 lists. You know, I shouldn't say that. And then stat test ANOVA of all your lists separated by commas, and that will give you your p-value. And then, again, if your p-value is small, what did somebody say in my last class? Something like, if p-value is high, then let H naught fly. In other words, H naught's good. It's good to go. If your p-value is low, then let H naught go. It's not good. And then, you know, do your summary. Yeah.
So on the final, because I used the ANOVA stat test to get my F value, so on the
Yeah.
final, we would just have to do it like manually.
Oh, no. I'm not going to give you, when I say, so for the test, do it this way. And don't worry about the F value, and write down the F value, but separately on a separate problem, I'm going to say, here's the between value, between group variance, here's the within group variance, what's F?
Oh, okay.
And you don't have all the data, so you can't put it into your calculator.
Okay. Makes sense.
Yeah.
Thank you.
So you realize that that's where that comes from. Good, thanks for clarifying that. Okay, cool. So what, you guys want just another couple minutes to finish up problem
Yeah.
number 2?
Yeah.
Okay, two minutes. Okay, let's look at your problem. So here's your quiz problem.
Oh, I know.
Zachary, what is your H naught and H1?
H naught equals M1, right?
Yeah,
equals,
mu1.
Equals mu2 equals mu3. And then the second one is at least one differ.
Yep, at least one differs.
Let me just walk you through this whole problem.
No, I need to spread it out.
Damn it. I'm just trying to shine.
Yeah,
Put me in, coach.
you did, you shined. All right, step 2, Bruce.
Beta is 0.05.
Alpha is 0.05. Great. And then step 3, yeah, Zach can go back to you, it's fine.
Okay, cool. Okay. 3, your p-value is 0.0545.
How'd you get that?
You do with the equation you wrote up there. That's
Stat,
yeah.
test,
Yeah, and then ANOVA.
yeah, and so you guys do write that down for me so I know that you know how to find it and it wasn't just I guessed correctly or I copied off somebody else. L1, L2, L3, and then go ahead and tell me which ones you put into which list. You put that one in list 1, put this into list 2, you put that into list 3.
Yup.
And then, I'm sorry, you got p-value equals what?
0.0545.
0.0545. And then for kicks, what did you get for your F-stat?
Oh, I didn't write that down.
Okay.
Oh wait, 3.9. 3.949.
49. Great.
Thanks, Frank.
Good. Everybody on board?
Yeah.
Okay, good. Next step, Jeff, what do you have for the next step?
Oh, that's a pass. I did not get that far.
Okay, so
That's a
Wait.
what are we comparing?
All lists.
We're comparing our p-value to our alpha.
Yeah, that makes sense.
Now remember, this is the opposite of what we've been doing. All along, we've been comparing critical values. So the further away from 0 you are, the more likely you are to be unusual, right? If you're bigger, this is the opposite because we're looking at probabilities. So now if you're less than 5%, you're less than alpha, then you're unusual.
So it's not unusual
It's not unusual. Why?
because it's greater than 0.05.
Exactly. So here, it is. And so if it's not unusual, would you reject H? Are you rejecting H naught? Does that mean you're rejecting H naught or not rejecting H naught?
Not rejected.
Not rejecting H naught. It's not unusual. Everybody on board with that?
kids.
Thank you, coaches.
Do not reject H naught because my p-value 0.0545 is greater than 0.05 alpha. Good? If you don't know how to write these symbols, if these symbols confuse you a little bit, just write the words. Is greater than. Right? It's all fine. Is less than. Whatever you need to say. Everybody on board? Okay. Is bigger than. Alright, so then my last step.
I have a question.
Yeah, totally.
If we rounded it to 0.5,
Oh, you should give me at least 3 sig figs. Yeah. Yeah. It's gotta be 3 sig figs. Okay. And then the last step, Chelsea?
Yeah, I don't know how to word that.
Okay. That's super straightforward. Do I have enough evidence or not?
Not yet.
So, do not reject, so that means I do not have enough evidence. Yep, Rhea?
There's not enough evidence to say means different.
Yep, to say means differ.
So you can't say.
You
Bible
would not say not enough evidence to reject claim means
No.
the same.
Don't even worry about it. Don't even worry about the. We are covering this so quickly and simply and basically. Don't even sweat the claims. Just always say, to say the means differ. You might throw a the in there. The means differ.
So you should just take out 5 then. No
What was
step
that?
5.
What's that?
No step 5?
Yeah,
Take it out.
no. You have to relate it to real life in the words.
So it's always gonna say differ regardless
Yes.
of what the outcome is?
The means differ. Yep. Either you have enough evidence or you don't have enough evidence to say the means differ. Everybody good with that part?
Yep.
We're keeping this as simple and straightforward as you can possibly make it.
I like that.
All right. Good. Now, before we head to break, I have a couple things I want to go over with you guys. The first one is this. How to tell them apart. We're going to look at word cues in the problem to kind of help you out first. So the very first type of thing is it two, you guys quiet, is it two different variables? So in other words, not orange and red. Those are different categories of the same variable. You guys understand what I'm saying? But two different variables like type of fish and, why did I get myself into this? And boat. I don't know.
Vote.
Or officials person I can know. I have no idea. All right. Or casino size and revenue. We did that one, right?
Yep.
Stuff like that. Or amount of drug and reaction time. We did that one also. So two different variables. And you want to see. So then you're going to have a list of numbers for each variable. And the numbers are going to make points. They go together. They're all matched up, like you did in lab 10. And you want to know. Also, you want to know if they have a correlation or a relationship in some way. Make sense? Everyone kind of on board? That's chapter 10. So when you have different, your data is numbers, and you're trying to figure out if they're related or not. The other thing is if you have two variables, but they're in categories. So your variables aren't numbers. In other words, the other one would be like height. Is height going to be a number or is height going to be a category? A number. You guys everyone kind of follow me? But you could have it, so if your variable was more like type of infection, hospital, right? Or major and gender, right? Those are, your data is going to be categories. You guys see what I'm saying? Then, if you're talking about categories. So if you have just one variable, say hair color, one variable, you'll have different possibilities for that. Then that's a list. You're going to have one of observed, and then you're going to compute the expecteds. Everybody all good with that part? Yes? No? That's going to be chapter chi-squared. It's going to be chapter 11.1, and I call that a chi-squared list. That's what I call that. So you have one list, and you use lists to solve it. This one is when you have two different variables, and you have categories across the top and the side. So not just categories here, but categories here also. Or not just categories here, but here also, right? Categories across both of them. So it might be like hair color and gender, right? Are there more blonde males than there are blonde females? I don't know, whatever. So hair color here and gender, two different categories, and so you're going to have a matrix. Good? So that's going to be a chi-squared matrix. That one is chapter 11.2. I call that chi-squared matrix. And the last one is multiple lists that are means. So you have means, and you have 3 or more lists, right? So you'll have lists, and the lists can go this way, or they can go that way, but you're only going to have categories one here or here, not in both spots. So you guys understand what I'm saying? So lists will be where there's only categories here and lists, or categories here and lists. If you have categories here and here, then you're looking at the matrix. The lists only have categories across the top or alongside, one or the other, and then numbers out this way. And there also should say means somewhere in there, or averages somewhere in there. Okay, great. This is ANOVA. So I want you guys to take a minute with your neighbor, silently, actually on your own, and figure out, can you guys see that okay? Figure out which one is which. So silently by yourselves, I'll try to make it bigger. And one shot to your neighbors for 20 seconds and see if we sort it out together.
First one is 11.3, second one's 11.2, third one's 11.1, now it's 10 point something. You're fine. Breeze on this final, we're gonna get good grade in this class, we're never gonna think about this class again. A lot of work.
My tutors last year when I was in college. What is the freaking point of this?
I don't know.
And the tutor and like 3 of the tutors all gave the same like response. It's to expand your
I did expand my mind. With useless information. Yeah.
It's like movies and
Yeah, a lot of music, a lot of music. You ever seen the movie Do Not Mess with the Zohan? That is such a funny movie. I was talking about that with my friend.
Alright, so the top one.
It's really A1.
What do you is that one?
Oscar or something.
ANOVA.
Right, because there's only categories across the top only. You guys see that? Not along the sides, there's nothing along the sides. Everybody on board?
And the lengths aren't the same.
Yeah, and lengths aren't the same, but,
Don't rely on that, but it's,
right.
it will
Yeah,
also.
yeah. But I mean, I want them to focus on the other part because they might be the same. They could be the same. And if they were, the fact that there's nothing along here is still gonna. So this is 11.3, ANOVA, everybody on board?
Yup.
How about the one right below it?
11.2.
That one would be the matrix thing.
Yeah, the matrix. What makes you say that?
Because there's columns and rows.
Yeah, because you have
Tall
categories
and
here
total.
and categories here.
Yep.
And male, female are categories. Everybody understand that?
Yeah.
Cheers.
Good. So this one is a chi-squared matrix. 11.2 chi-squared matrix. How about the one below it?
Chi-squared.
Not matrix.
Yeah.
So you have categories here. Are these categories over here too?
No.
No.
Not exactly.
Not exactly. What are these things? What's this?
Observed.
What's this one?
Expected. Their values.
So they're the same thing. It's just one observed is observed. The other one is your expected values. Do you guys understand what I'm saying? So this is a list of your observed and another list of your expecteds. Good? Everybody understanding that?
Mm-hmm.
Okay. And also these are decimals, but that isn't necessarily, they could be whole numbers or decimals. But definitely they couldn't be a whole matrix. All right. Everybody understand how those observed and expected, those are not categories. That means literally your observeds and your expecteds. So these are your O's and your E's. So this is 11.3 chi-squared list.
11.3, you mean 11.1?
Sorry, 11.1. I'm so sorry. Thank you, that's why you're here. Chi-squared list. All right, perfect. And then this last one up here in the corner, what's that one?
10.
What's left?
Well, okay, but say it isn't. Say I could double up and screw you guys up. What's that one?
L1 and 2?
The two different lists?
Yeah.
Yeah. Their relationships between each other.
So yeah, so this is my variable. This is a different variable. They're not. Are they the same category? Two different categories. Same variable, two different categories?
No.
They're two totally different variables.
Yeah, never mind.
So this is chapter 10. This is my x and my y. This is correlation. Everybody sort of understanding that? You guys want to ask some questions or give some explanations to understand this better?
That's what lab 10 was on.
Yeah, that's what lab 10 was all about. Two things, age and income, or age and height, or there's an age and net worth, right? To compare and see if those two things are related or not related. Yeah.
So, what would be the step 5 for each of these? Like in chapter 11.3, we know that there is no, or evidence.
There's no claim. Yeah, there it is enough evidence or not enough evidence to say the means
differ.
differ. This one is going to be, is enough evidence or is not enough evidence to reject the claim that
Blah, blah,
blah,
blah.
blah, blah.
The
And then this one is going to be, is or isn't enough evidence to reject the claim that the proportions are as expected.
Okay.
And that one?
And that one would be, there is or is not enough evidence to support the claim. It's usually support the claim of a correlation between blank and blank, typically. So it would be to support a claim of a correlation between.
Like
Age
not
and
enough
net wealth.
evidence to support
Yeah.
correlation between.
Yeah.
Yeah, you guys are asking good questions. All right, why don't we take a 10-minute break? And